Alright, ladies and gentlemen, welcome back to another video with Mr. Kenton, Physical Science. Today we are going to be wrapping up in this video Unit 3 on the periodic table. We're going to look at our last little bits and pieces here by looking at element reactivity and oxidation states. Okay, and so I know that we've looked at reactivity previously, and we defined reactivity as an element's ability to react with other substances. And then oxidation state, that's not something we've looked at before, but we're going to look at it today, and I'll be able to give you guys a definition and something we can work with. Now, some things to consider as we look at element reactivity and oxidation state. Now, what we know is that when atoms are seeking to react, what they're seeking to do is they're trying to become chemically stable by filling their outer energy level with electrons. So if you're thinking about the Bohr model, their outermost ring needs to have the maximum number of electrons that they can hold. So whether it's 2 or 8 is what we're looking for there, depending on the element. Or if you're thinking from the Lewis dot diagram perspective, having those 8 dots around the element symbol. Now, in the previous unit, we saw that certain elements could lose electrons to form cations, and that other elements would gain electrons in order to become anions, right? So there are those terms again, and I introduced them in the last video as well. And so looking at the periodic table, what we know is that in general, so in a pattern that we see is that atoms that have between 1 and 4 valence electrons will typically form cations and lose electrons. That's not always the case, but in general, elements with 1 to 4 valence electrons lose electrons and form cations. So if you're thinking about on the periodic table, that means elements in groups 1 through 14 tend to form cations. And then our atoms that have between 5 and 8 valence electrons, they tend to form anions by gaining electrons. So that means that elements in groups 15, 16, 17, and 18 tend to form anions. Again, that is not a universal, that is just the general thing that we see. There are some exceptions to that, okay? Now, looking at oxidation number, we're going to simply look at it. We know this idea that atoms gain or lose electrons and form ions. And so the charge on the ion is what we're going to call the oxidation number. And so what I've done in this particular graphic for you guys is I've shown you what the oxidation numbers are for the elements in each column. And so if you look at each column, you see over here, column 1, the alkali metals, they have an oxidation number of +1. So all the elements in group 1 are going to have a +1 oxidation number. The elements that are in the alkaline earth metals, they have an oxidation number of 2. So from beryllium all the way down to radium, those elements are going to have a +2 oxidation number. We're going to skip the transition elements that are in purple here, and we're going to shift over to column 13. So elements in column 13 tend to have a +3 oxidation number, so from boron to thallium. Elements in group 14 have a +4 oxidation number, so from carbon down to lead. And then once we get past carbon, we move to the nitrogen group, column 15. That's when we see that there's a shift, and now the oxidation numbers are negative. So this is communicating that something like nitrogen gained 3 electrons, so its oxidation number is -3. So from nitrogen to bismuth. For oxygen and the elements in its group, a -2 oxidation state. For fluorine and its elements down to astatine, a -1 oxidation state. And then what we see is for helium down to radon, they tend to have oxidation numbers of 0. They don't tend to lose or gain electrons in chemical reactions. okay? And so it's going to be important for you guys to kind of recognize this pattern for oxidation state. You will need to know that without being able to look at this graphic, okay? Now, let's look a little bit more at oxidation numbers and reactivity. I want to mention tin and lead. And so if you look back at the periodic table, tin is element number 50, and lead is element number 82. They're in column 14. They're with carbon. So those two elements, they're metals, and they're unique in that they can form multiple oxidation states. So both tin and lead can form a +2 and a +4 oxidation state. Okay, so tin and lead can form two oxidation states, +2 or +4. So what that means is tin and lead can either lose 2 electrons or 4 electrons. Now, for us in chemists, we use oxidation numbers and oxidation states to tell us how reactive an element is. Okay, so that's essentially what an oxidation number tells us, how reactive an element is. And as we've seen, reactivity is a measure of how readily one substance will react with another. Now, if an element has an oxidation number of 0, think about our noble gases, what that's communicating to us is that those elements are not going to want to react. They don't react with other substances. And so how do oxidation numbers tell us something about reactivity? Well, elements that have low oxidation numbers, so obviously they can be positive or negative. So when I say low, I mean close to 0. So the -1 and +1 oxidation states indicate that elements are more reactive than others. So for example, the alkali metals and the halogens, because they have oxidation states of +1 for the alkali metals and -1 for the halogens, are more reactive than elements that have a higher oxidation number. Excuse me. Such as an oxidation number of -3 or +3. Okay, so oxidation numbers that are closer to 0, that means that it's going to be more reactive. Farther away from 0 you get, the less reactive it's going to be. All right, now what I want you guys to do, the next 2 slides have some practice. So as you look at the video, I want you to pause the video once I've kind of asked, you've looked at the questions, write down your answers, and then check back, okay? So the first question asks you to identify what is the oxidation state of the following elements. So based on what we talked about, what's the oxidation state of each of those 5 elements? Take some time to do that, pause the video, and then once you're ready, hit play, and I'll start explaining the answer. All right, so hopefully you paused the video, you're able to come up with your answers. So for strontium, it's in group 2, so it has a +2 oxidation state. So oxidation state +2. Sodium's in group 1, it has a +1 oxidation state. Nitrogen is in group 15, it has a -3 oxidation state. Neon is a noble gas, so it has an oxidation state of 0. And lead, Pb, that's one of our special ones, it has 2 oxidation states, +2 and +4. Okay, hopefully you were able to get that for your oxidation states. All right, now here's our second question. And again, I want you to read the question, pause the video, and then think about it and come up with your answers, and then once you've kind of come up with your answers, unpause the video, and then listen to my explanation at the end. So which element is more reactive when you compare the 2? All right, so pause the video, come up with your answers, and when you're ready, hit play again so you can hear my explanation. All right, hopefully you paused the video, hopefully you've come up with your answers. So it asks us which element is more reactive. Now, in order to do this, we need to first identify, is our element a metal or a non-metal? Because we're going to need to think of it from that perspective. So we look at lithium and potassium, Li and K, those are both metals. And so because they're metals, what we're looking for is elements that are further to the left and that are further down a group, okay? And so we see that lithium is in period 2 and potassium is in period 4, and they're in the same column. So that means that potassium, element K, is more reactive than lithium, all right? With rubidium, Rb, or silver. So both of those are metals, so we know what we're looking for is furthest to the left and furthest down. Now what we see is that both of them are on the 5th period, and so we're going to be having to look for which one's furthest to the left. And so when we look at that, rubidium is the element that's furthest to the left, and therefore rubidium is the more reactive metal. I hope that makes sense. All right. Now for the last two, we've got carbon versus fluorine. Now we look at those. Those are nonmetals. So for nonmetals, we want to look for the nonmetal that is furthest to the right, and it's highest up in its group. Now, carbon and fluorine are both on period 2, so it's not going to be the one that's furthest to the right. We're going to look, it's not going to be one that's in higher up. It's going to be the one that's furthest to the right. So we look at carbon and fluorine. Fluorine is furthest to the right, therefore fluorine is our more reactive nonmetal. And then the last one here, we've got oxygen or selenium. Now, both of these are nonmetals, and if we look at them, they're both in column 16, so it's not going to be which one is further left or right because they're in the same column. So what we're going to need to look at is which one is higher within the group. So we see that oxygen is on period 2, and selenium is on period 4. And so because of that, oxygen is going to be our more reactive nonmetal. I hope you were able to get that. If not, feel free to ask me a question. That concludes the video, ladies and gentlemen. Please make sure that you fill out the Google form that's associated with this video. Let me know what questions that you have so that I can help address them in class. And I hope you guys are doing well. Thank you guys for tuning in and watching this. Hope it was insightful. I'll see you guys again real soon. Take care.